Hello everyone, welcome to your second math worksheet for HOR 164. This is for Unit 2, and as you know, in Unit 1 we actually went over dimensional analysis. Actually for this I'm going to show you a little different way to do it. Maybe not as hard, maybe easier for you, it just depends, and that's why I show you guys both ways how to do it. But now we're going to focus on, similar pesticide math questions. Again, these questions will probably help you take your state pesticide license exam, and will help you also through the rest of the class. So we're going to go ahead and get started. And as you can see, my two little girls visited my classroom last week, and they told me and you guys to have a great day. They wanted to let you know that Eric's daughter was here. And it breaks my heart to erase this, but I'm going to have to so that I can work math problems for you guys. But go ahead and print your worksheet off Blackboard. It's in Unit 2, and we're going to go ahead and get started. Let's make sure I've got a good felt tip marker to actually do the problem. And let's start with number 1. It states that you need to make 4 gallons of a 7% solution of a broadleaf herbicide to spray a lawn that is 40 by 60 feet. How many ounces of herbicide are needed? Well, how many ounces of herbicide are needed? So let's go ahead and get started. Again, we've got a 7% solution, so I'm going to do 7 over 100. Our 7% solution is equivalent to that, and we get 0.07, and we know that there's 128 ounces in a gallon, so times 128 ounces. That's going to give me 8.96, and we need to make 4 gallons of it. So 8.96 times the 4 gives us the 35.84 ounces needed to spray the lawn. Again, it states that we have a 40 by 60 lawn, but we didn't really need that information to do the math because we know we have a 7% solution, and we know that it's already going to take 4 gallons to do that 40 by 60. So sometimes people will get confused and start trying to bring in the size of the lot. You always got to look at the information given to you and look at what the problem is actually asking for. So for this, the 35.8 ounces of the herbicide will cover the 40 by 60 lawn that we're getting ready to spray. So that is number 1. We'll go ahead and move on to question number 2. And it states, how many pounds of granular fungicide are needed to treat 3 acres, assuming a label rate of 4 pounds per 1,000 square feet, round off to the nearest pound. So we have 3 acres. So we're going to start with what we have. We have 3 acres. We're going to go ahead and multiply it times 43,560 because that is how many acres, that is how many square feet is in an acre. And we know that the label rate states that it's 4 pounds per 1,000. And we got 4 per 1,000 on the label rate. So the answer we get here is 130,680 square feet. And actually, we're just going to multiply this times the 4 over 1,000, and that is going to give us 522,720 over 1,000, which will give us 522 pounds of product. And that is problem number 2. So 5.72 pounds. And we'll look at number 3. How much total spray solution will be needed to treat a 16,000 square foot lawn if your sprayer is calibrated to deliver 6 gallons per 1,000 square feet? So we have 16,000 square foot lawn, and we're going, I always like to take my lawn areas and divide it into 1,000 square feet. You know, you've got your blocks that you cut out in your turf. So 1,000 square feet, because a lot of the label rates are based on 1,000 square feet. And we know that our sprayer is calibrated to deliver 6 gallons per 1,000 square feet because we've already calibrated. So if we got 6 gallons per 1,000 square feet, how much will it take to do the 16,000 square foot lawn? Very simple. We have 1,000 blocks in our 16,000 square foot lawn. Gives me 16 of them, and we have 6 gallons per 1,000 square foot areas, which we have 16 of them. Is going to give me 96 gallons. 96 gallons will cover your 16,000 square foot lawn. I know the math numbers are a lot high, but I'm trying to give you as many problems as possible. You know, a lot of times you're not going to be spraying 96 gallons of anything on a 16,000 square foot lawn. These are just problems that we've worked over and over again, and it's kind of showing you how to get the answer. So some of these numbers are going to seem a little high for the small areas that we're dealing with. So don't let that confuse you. Number 4, an 8% solution of pesticide will contain how many fluid ounces of pesticides per gallon of mixture? So we have 8%. Again, 8 over 100 is equivalent to 0.08. We're going to multiply that times 128 ounces that are in a gallon, and that is going to give us 10.24 ounces. So that's how many fluid ounces of pesticides per gallon of the mixture, because we have an 8% solution. And a lot of times we have to do this type of math in a larger pesticide problem. We need to figure out how much is going to be in it and then get the answer. So that was just a little short one on how to do that, and showed you how to do it through dimensional analysis in the last lecture. So number 5 states you're using the 1/100th of an acre method to calibrate your boom sprayer. How long would your test site be if your boom measured 36 inches? Use the attached table to determine the length. I'll need to attach that for you guys, but the answer is 145 for number 5. It's in your textbook, but I'll make sure that you guys get a copy of the table. So, but number 5 is 145 feet. Number 6, you're applying a pesticide to a lawn. The total lot size is 2 3/4 acre with a 100 by 43 house and a 673 by 20 foot driveway. How many square feet will you need to spray? Show your calculations. So we have 2.75, which is the 2 3/4, times 43,560 square feet. This is going to give me a total of 119,790 square feet, total square feet for the property. We also have a 100 by 43 house, which gives us 4,300 square foot, and the driveway is 673 times 20 gives us 13,460 square feet of concrete or asphalt or gravel. So this is our total area of the acreage, and then of what we're going to be spraying, but we need to minus out the size, the footprint of the house, and the footprint of the driveway. So we need to minus, this number is going to come from this, and we're going to minus those numbers. So if I take 119,790 minus the 4,300 and minus the 13,460, I'm going to come up with 102,030 square feet. So we still have a big property. Still have, you know, more than 2 acres that we're going to be applying product to. And the next part of this problem for number 6, B, says the label says to apply at the rate of 7.5 fluid ounces per 1,000 square feet. How many ounces of formulation will you need for this area? Show your calculations. All right, again, I like dividing my lawns into 1,000 square foot blocks. So if I take this 102.30 divide by 1,000, a little messy there. That is going to give me 102.03. This 102, guys, is my 1,000 square foot blocks. So if I actually had this big property and it was 119,000 square feet, I would take it and divide it into blocks. And each one of these would be 1,000 square feet. So that's how I'm kind of doing it in my mind. I don't draw it out like that, but to kind of give you guys an example, how many 1,000 square foot blocks would be in this total property? And you've got 102.03, and we're going to state, the label states that we're going to apply 7.5 fluid ounces per 1,000 square feet. How much are we going to get? So we just multiply this times 7.5, and make sure we got room to show you this. That is going to give us 765 ounces of product that we're going to apply, or our pesticide. So it's kind of lengthy problem, but you know, you'll see this on your pesticide exam, and hopefully this is kind of clearing up some things. You may or may not like the way I'm doing it now. You may like dimensional analysis better, or you may like this better. Guys, again, I'm showing you different ways that you can do it. But a lengthy problem. Let's look at number 7. You are working on an 80-acre retirement community in which 43 acres has fine fescue lawn. The remaining acreage is streets, parking lots, and village homes. You want to apply 5 pounds of active ingredient of herbicide B+ per acre of fine fescue. Herbicide B+ is a 74% wettable powder. How many pounds of formulation must you apply per acre? Again, what is it asking me? What is it asking you guys? It's asking you how many pounds of formulations are you going to apply per acre. It's not asking you for the total product of the entire site. It's asking you how many pounds of formulation must you apply per acre. So we know this is a 74% wettable powder. Again, 74 over 100 equals 0.74. Well, it does equal that, but we have 74% wettable powder. I'm putting 74 over 100, and I know that I'm going to apply 5 pounds of active ingredient per acre. So, I mean, I'm trying to find out how much per acre. So 74% wettable powder, and it has 5 pounds of active ingredients. So we do our cross math. 74x equals 500, and it gives us 6.75 pounds per acre. of the product. You didn't need to know the information about the 80-acre site or how much of it is in fine fescue. Again, remember, what is the problem asking you for, and only use the information that you need to get what it's asking you for. So kind of a little confusing there, but not too bad. A lot of times students just get too involved with the problem and they start bringing in all the information that's given to them, and you really only need to answer what they're asking you to give. So I know I'm kind of going over these problems quickly, but it's on a video so you can rewind and watch as many times as you need. And if there's any questions with this, again, the online office hour allows me to clarify this for you guys. But so we're through problem 7. We've got 3 more if you turn the page over. And number 8 states that your rear mount sprayer on your John Deere 2150 holds 150 gallons of herbicide. It has been calibrated to apply 0.5 gallons per 1,000 square feet. How many times would you need to refill your sprayer if you're spraying an athletic park that has 37 acres in it? So, lengthy problem again. So we've got 150 gallon tank. Information that is given to us, it'll do 0.5 per 1,000 square feet. And we know that 1 acre is 43,560 square feet, and we have 37 acre site. This is all the information that the problem has given me. So I've wrote that down. It's on my piece of paper. I'm going to clear this so I can work the problem for you guys. So we wrote down the information that the problem gives us. Well, we know that 43,560 times the 37 acres is going to give us 1,611,720,000 square feet. It's a big piece of property. Well, again, I'm going to divide that by 1,000 because I like using 1,000 square foot blocks for my property. This is going to give us 1,611.72 square foot blocks. And we know that our sprayer is calibrated to deliver what? 0.5 per 1,000 square feet. So we're going to multiply this times 0.5, which is given to us. And that's going to give us 805.86 gallons. That's how much total product, how many gallons we're going to put over the site. We have a 150 gallon tank, so we're going to divide this by 150, and that's going to give us 5.37. So we're going to have to fill our sprayer 5 times, and then we'll have to figure out exactly how much for that 0.37. So you're actually going to be filling your tank 6 times, but the last time you're only going to put 0.37 in it. Again, lengthy problem. Use the information that's given to you and give the answer that is asked for. Fun stuff here. All right, so number 9. You're applying a liquid fertilizer to a circular patch of turf at a local golf course with a diameter of 26 feet. We've seen the similar problem to this. I think so. The application rate of the fertilizer label is 7.5 ounces per 1,000 square feet. How many ounces of fertilizer will be needed to treat the turf? Show your calculations. So we know the area of the circles pi r squared. We have a diameter that is equal to 26 feet. So this automatically lets the radius be 13 because the diameter, here is your radius. Well, if you go all the way across the radius, that's equivalent to the diameter. The diameter is all the way across, whereas the radius is from the center point out. And we know that we're giving 7.5 per thousand. So let's go ahead and do our area of the circle. So the area is equivalent to pi. The radius is 13 squared. Pi is 3.14 times 13 squared. And that's going to work out, guys, to 530.66 square feet. That's the area of the circular path that we're doing. I'm going to divide this by 1,000 to get my 1,000 square foot blocks. And I actually get 0.53066 times the 7.5 equals 3.97 ounces needed to complete this pesticide problem. So it's 3.97 ounces, almost 4 ounces to do this circular path. All right, last problem. You need to apply 3 pounds of nitrogen fertilizer per 1,000 square feet to a high school soccer field. How many total pounds of nitrogen will go on the field? They're using the football field for the soccer field. The football field is 100 yards by 53 yards wide. Don't forget about the end zones that are 10 feet deep as well. Show your calculations. So 100 yards, guys, is equivalent to 300 feet. 53 yards equal to 159 feet. And 10 yards is equal to 30 feet. So I'm giving you the information that the problem is giving us. So we're going to do the football field itself. Now remember, the football field is 100 yards by 53 yard wide. So I've already converted it to feet. So I'm going to do 300 times 159 is equal to 47,700 square feet. This is goal line to goal line of the football field. Goal line to goal line. But we still need to do the end zones. And we have 2 of those. So we have 30 feet times the 159 feet as well. Because goal line to the post, or the field goal, we have 10 yards, so it's 30 feet by 159 because it's wide. And this is going to give us 9,540 square feet for the end zones. So here's the actual goal line to goal line, and here's what's in the end zone. So we need to add these 2 together, which gives us 57,240. And what does Eric like to do? I like to divide by 1,000 square foot blocks, which gives me 57.24. And we're going to be applying 3 pounds of nitrogen per 1,000 square feet. So 57.24 times 3 gives me 171.72 pounds of nitrogen to solve this problem. So I hope you guys are seeing this a little bit better. We have the dimensional analysis way to do it, and then I kind of just did what I kind of call shorthand way of doing it. Either way is correct. Some of you may find this easier. Some of you may find dimensional analysis easier. So I wanted to give you guys a way to look at both. If there's not any questions on this, or if there is any questions, please take advantage of the online office hour. Thanks, and I'll see you in the next lecture.